Hello everyone. Today section 4.7 Maxima and Minima problems. Okay, so we heard that those title before in Calculus 1, right? Yes, it's the same concept. Okay, so we learned critical point. We learned local maximum minimum, right? And we learned absolute maximum minimum, right? So same as here in Calculus 3. So let's talk about this. In Calculus 1, how did we find the critical point? So let's denote just the CP, critical numbers or critical points. So when derivative equal to 0, and then we find the x, right? Or the derivative does not exist. What this means? That means f prime undefined. So when this one happened, undefined, when denominator is 0. So if we have derivative, if we have a quotient, then we set the denominator equal to 0, then we can find what's the x value. That was the critical point in Calculus 1. Now, how do we do in Calculus 3 then? Same, critical point, but then we don't have a derivative, right? We do partial derivative in x, partial derivative in y, right? So, same concept. So, derivative equal to 0, that means we do partial derivative with respect to x, partial derivative with respect to y, and then we set up equal to 0. We need to find the value of x and y because we need 2 points, right? Before we did at 1 point, only x for the critical value, right? Okay, now we want to find that partial derivative does not exist. Respect to x, respect to y. What this means? We need to look for that derivative is undefined. When this one happens? When the denominator equal to 0. So same concept, only with the partial derivative, right? All right. Then let's do this example. So we have find the critical points of this equation. Okay, then we make a partial derivative with respect to x. Then we have a 2x, partial derivative with respect to x, so plus 2y, y is constant. And this one is 0. We have 4 and 0, 0, right? So plus 4 equal to 0. Okay, now we need to find partial derivative with respect to y. Okay, then first term is 0. Second term, we have a plus 2x. And third term, minus 8y. And we get 0. This is a negative 6y, and I'm not sorry, negative 6 and then 0, right? Negative 6 equal to 0. Okay. We have 2 variables. So we need to find x and y in Calculus 3, right? How? Good. We need to make a system of equation, right? This is a system of equation. Yeah. So this one equal to 0. Okay. How about that? And subtract. Because we have a 2x and 2x, right? So subtract. Then we have to have a parenthesis. Then we get positive 10y. Okay, plus is a positive 10 equal to 0. So we have a 10, y equal to negative 10, y equal to negative 1, right? Okay, so let's make, this is equation number 1. How about this is equation number 1, this is equation number 2. So we want to substitute 2 into equation number 1. So that will be okay. That. So y equal to that, right? So this will be 2x plus 2y, which is negative 1, plus 4 equal to 0. Okay, let's find out x values. So 2x minus 2 equal to, minus, yeah, I use that. 2x plus 2 equal to 0, x equal to negative 1, yeah? Okay, so we have x equal to negative 1, and we have y equal to negative 1. So then we can conclude critical point at negative 1 and negative 1, right? Okay. You guys okay? All right, let's do second problem. Okay, so this is a second problem. We have square root of that, right? We want to derivative partially respect x and respect y, right? So partial derivative with respect to x first. Then look, we have a experience in previous section, right? So this is 1/2. This is 1/2. We want to derivative. Then drop the power, reduce by 1. So that's negative 1/2, right? Then that will be 1/2. Then square root of 4y squared minus 9x squared plus 24y plus 36x plus 36. Yeah. And then we want to make a chain rule inside. So we do again, what's the derivative with respect x? Okay. Okay, so there will be x. So 18, negative 18x and plus of 36, right? Over 2. Oh, let's just copy denominator 1. Oh my gosh, what's going on? Hold on, be patient. Okay, very good. Okay, let me just make copy and paste. Copy. Okay, then we can simplify the 2, right? So a little bit ugly. So 2 goes to negative 18, 9, and 18. So we will get negative 9x plus 18 over that, right? Okay, paste. Okay. This is the one. What is this? This is a partial derivative with respect to x, right? Okay, let's find the partial derivative with respect to y. Very similar. So let me write down this one, right? This is same, the first step. Copy. Okay, now we want to derivative with respect to y this time. So that will be the first term 8y, second term is 0, third term is plus 24, and rest is 0, right? Over same, right? So copy and paste. Okay, so we can simplify with the 2, so that will be 4y plus 12 over this square root. Copy, paste. Okay, now we need to find the critical points. Then we said the partial derivative with respect to x equal to 0 and partial derivative with respect to y equal to 0, right? Okay, set equal to 0 equal to 0, right? Okay, then let's find out. So this one whole thing equal to 0, right? This one whole thing equal to 0. All right, so in that case, we can just use numerator equal to 0, right? So we can think about over 1, multiply this way, then negative 9x plus 18 equal to 0, right? Yeah. All right, then it's easy to find the x value, right? So what do you get? X equal to 2. Now we have partial derivative with respect to y. Equal to 0. Then we have 4y plus 12 equal to 0. Yeah. Okay, y equal to what? Negative 3. Yeah. Okay, so let's make a critical point this way. Critical point, we get 2 and negative 3, right? But this problem has another critical point because we have critical points when the derivative equal to 0, right? Or the derivative is undefined, does not exist, which is undefined, right? So we have partial derivative in calculus 3. So partial derivative with respect to x equal to 0, find x. Partial derivative with respect to y, find y. Value in general, right? Okay, then look, we have partial derivative, then we have a quotient. This is a quotient, right? So when the denominator is undefined, then we say that derivative does not exist. Yeah, f prime does not exist. We had that in calculus 1, right? Same as here. So what we do, we need to find the partial derivative respect x and partial derivative respect y does not exist. So we need to find the another critical point. Yes? Let me using different another page. So note finding another critical point. Let me denote CP for does not exist. Yeah. Okay, so let me write down what's the does not exist, right? So means the partial derivative respect to x and partial derivative respect to y undefined, right? So undefined, we know that the denominator is 0. Okay, can you see? Okay, too tiny, huh? Is 0. Okay, so we have a so we can pick only one, right? Because the denominator is the same. Copy. So we say the set. This is equal to 0. This is the denominator, right? Okay. Then there is a two variable involved, right? So let's arrange. We have 4y squared. Now 24y. And then we have x. So we have a negative 9x squared plus 36. Huh. How about the 36? Okay, so we have this 36 move to the other side, right? So that will be negative 36. All right, so I made a space, empty space. So you can notice that we're gonna make a completing square, right? So completing square. So we have to have b over 2, right? So b over 2 squared. Okay. But then the number we can factor out. So let's do that. So we have 4y squared plus 6y. Then b will be 6 over 2 squared, right? Which is 3 squared, which is 9. Okay, so we are going to using this number later. So remember that number when you make a completing square. So we have a plus 9 there, right? Okay, now look, but then we have 4 times 9, which is positive 36. Yeah. So we have to add positive 36 here. Make sense? Okay, now the second, the x variables as well, we have negative, we factor out the 9, x squared plus, okay, negative So negative and negative is positive, it's a 4. Okay, now we have 4 over 2 squared. Then there's a 2 squared. And then we are going to use this number later and 4, right? Okay, so that will be positive 4. Yeah. Okay, look. Negative 9, positive 4 is negative 36. So we have to make a negative 36 other side because we create negative 36 here, right? All right, now we want to make a completing square. So there will be 4 y plus 3 quantity squared. Yeah, minus 9 x plus 2 quantity squared equal to negative 36. All right, so then let's divide by negative 36 both sides. So divide by 36 every term. Negative 36. Then we get the first term, it's a negative 9. Second term, positive. Minus 2 squared equal to 1. Okay, so I want to arrange x and y switch. So we have 1 over 4, x minus 2 squared plus minus negative 1 over 9, y plus 3 squared equal to 1, right? Okay, so what is this? Yeah, this is a hyperbola. But we need to find the critical point, right? So when x equal to 2, we get 0. When y equal to negative 3, we get 0, right? So critical points are 2 and negative 3, right? Which is also, we say the center there. So center. Okay, so let's take a look here. So I draw decimals, hyperbola, and then also I found the asymptote and then I plug in there too for your reference. All right. Okay. Let's do. Let's talk about the local maximum and local minimum. Okay, now we have a lot of definition. Let's take a look. We have a function, and the function has a local maximum at this point, x naught, y naught. Then the function value, this one is bigger than others, right? If we have local minimum at this point, x naught, y naught, then the function value at the x naught, y naught is less than other values, right? So this is the local max, this is the local minimum. So same concept with pre-calculus, calculus 1, right? Local maximum, local minimum. Okay, so we have an absolute maximum. Other name is global maximum. So think highest point, right? So we said absolute maximum. We have an absolute minimum. Other name is global minimum. Think lowest point in the function, right? Okay, we have a formulas theorem, French mathematician. So we have a derivative exist, partial derivative respect to x and y, right? Okay, then we have a local extremum, and then that local extremum, which is a critical point, right? So same concept as calculus 1, derivative exists, then f prime of x equal to 0, right? Then in that case, local max, in that case, local minimum, right? So those are critical point, critical point, right? So critical points, that is a critical point, right? This is a critical point. So critical points is the local maximum minimum. No, we cannot say that. Critical point it's not local minimum maximum. We said that local maximum minimum is critical points. Yeah. Because we learned in calculus 1, right? So it might not be have a local maximum minimum when the critical point, right? Okay. So we have a saddle point here, but this is a new vocabulary terminology, but look, saddle points neither local maximum nor local minimum. So we had this one, right? We learned this phrase, neither local maximum nor local minimum, but we did not say that the word, but calculus 3, we have the word. If we don't have local maximum and we don't have a local minimum, we say that this is a saddle point. Yeah. Okay. So we have a critical point when x equal to 0. This is what I'm talking about earlier, right? Yeah. But then we don't have local max, no local minimum at when x equal to 0, even though this is a critical point, right? Yeah, those point we have a name, saddle point. All right. Okay. So neither local max nor local minimum. We have definition. Okay. So about the saddle point. So we have point. It's a saddle point. So 3 points there for x, y, z, right? If, this is similar with, yeah, derivative exists, right? Like critical points, right? So in that case, it's a partial derivative, right? But then the function does not have a local extremum at the point, which is a critical point, right? So this is the critical point. X naught, critical point. Yeah. Okay. Now we have a second derivative test. So in calculus 1, we had a second derivative test. The first derivative equal to 0, right? Then second derivative greater than 0, there is a local minimum. And second derivative less than 0, local maximum exists. And second derivative equal to 0, then test is inconclusive. We cannot say anything. So we're going back to first derivative test, right? Okay, let's take a look in calculus 3. So we have a second derivative test. So this is kind of same as f prime of c equal to 0. Yeah, same, right? Yeah, but then calculus 3, we cannot say that because we have more variables, right? So that's why we have a partial derivative, right? Okay, so partial derivative equal to 0. But then difference is discriminant here, right? So this one, we have a discriminant, we have a formula, and then there is bunch of rules. So this discriminant is greater than 0 and second derivative, yeah? So first and second derivative is greater than 0. There is a local minimum. This is a kind of similar, just a little bit similar with the calculus 1. Okay, now second one is the discriminant, this one is greater than 0. And first and second derivative, partial derivative, right? Respect to x is less than 0, local maximum. Okay, now the discriminant is less than 0. We have a center point. And discriminant equal to 0. Test is inconclusive, right? So cannot tell. Yeah. Whether local minimum, maximum, or set point. Yeah. So here's the picture. Local minimum, we know that. This is the local maximum. Set point, neither local max nor local minimum. Yeah. These kind of things. Yes. Okay, let's do example. Let's do couple example here. All right, so find the critical points and use the second derivative test to find local extrema, local maximum or local minimum, right? Okay, so let's find out critical point first, right? So how? With a partial derivative with respect to x, find x value. With a partial, no partial, not partial, partial derivative with respect to y, and then we need to find y. If we have x and y together, then we are using system of equation to find x and y values, right? We had the experience earlier, so let's do it. So partial derivative with respect to x, then we have 8x plus 8. That's it. Okay, then let's find out. We have a nice easy one. So set equal to 0, then x equal to -1. Good. Partial derivative with respect to y, we have 18y minus 36. So set equal to 0, y equal to 2. Very good. So we have a critical point, which is -1 and 2. Very good. So we finished that. And then we want to use a second derivative test, whether we have a local maximum, minimum, right? Then this one we involved with the discriminant, right? So what's the formula of that? So copy. So we have a little bit, make a highlight, discriminant. Okay. Let's find out second derivative first, right? All right, so let's using first derivative with respect to x and second. So we're looking at that, then we get 8, right? So we have 8. And you want me to write down separately? Which one is better? And then we do partial derivative with respect to y. So we have 18. And minus, the first is x, we're looking at that. And second is y, partial derivative with respect to y. We don't have a y, right? So there will be 0. We don't need to square. Okay, then what do you get? It's a 144. So normally x naught, y naught is the critical point. Yeah, because they say that here, suppose the partial derivative with respect to x equal to 0, partial derivative with respect to y equal to 0, right? That means this is a critical point, yeah? So critical point, x naught, y naught, right? Okay. So in the case x naught, y naught is critical points, but then we don't have any variable to substitute, so we can just have a number, right? Okay, so let's talk about this d equal to discriminant, which is 144, which is greater than 0. Okay, so if we have two condition, discriminant equal to 0, two condition here, then the partial derivative, second derivative x greater than 0 or less than 0, right? Greater than 0, we have a local minimum. Less than 0, then we have a local maximum, right? So let's do that. Let me write down quickly then. We note partial derivative with respect to x, then x, we have 8. Partial derivative with respect to y, then y, we have 18. And partial derivative with x, then y, we get 0. Yeah. All right. So then partial derivative with respect to x, then x, which is 8 greater than 0, right? Greater than 0. Then we can say that greater than 0. Local minimum. So check one more time. Greater than 0, local minimum. Yeah, at the critical point. So thus f has local minimum at -1 and 2. Yeah, critical points. Is it okay? Okay, so we have a picture here. So this is the function, the point. How do we find the point? We plug in the critical number, then we get the -16. That's how we got it, right? So we found out there is a local minimum, right? So this is the point. Okay, let's do second problem. Okay, so this equation, this problem is a little bit different. That's why I want to do with you. All right, so this is the same question about we need to find the critical point and using second derivative test to find local extrema, right? Okay, let's do it. To find the critical point, so let's find partial derivative with respect to x. Drop the power, so we have x to the second power then, yeah, and plus 2y and negative 6. Okay. Wow. This is so hard to find x value, right? Okay, let's do partial derivative with respect to y. Then let's find out 2y plus 2x negative 3. Yeah. Okay. Now, both are too hard, right? Okay. And also we cannot use a system of equation because we have x squared, right? If we don't have x squared, then yes, we can use that, right? 2y, subtract, yeah? And we can solve for x, then we substitute, then we can solve for y, right? But we have x squared, so we cannot do that. How about this? Um, let's solve for y in the case, and then we substitute there, yeah? Okay, so let's do this. Equation number 1, let's label first. Equation number 2. Okay, so we have equation number 2, solve for y. Okay, then we get 2y plus 2x minus 3 equal to 0. So 2y equal to negative 2x plus 3. And y equal to divided by 2, so negative x plus 3 over 2 then, yeah? Okay, so let's say that this is equation number 3. And let's substitute equation number 1. So we have this one. Copy. Equation number 1. And we substitute into there y, right? And then we know that it's equal to 0. So we have x squared plus 2, negative x plus 3 over 2, minus 6 equal to 0. Okay, let's solve for x here. Okay, so x squared minus 2x plus 3 minus 6 equal to 0. So x squared minus 2x minus 3 equal to 0, right? We can factor out nice number x minus 3x plus 1. Okay, then x equal to positive 3, x equal to negative 1, right? Okay, now we need to solve for y because we have x, right? So we have a 2x, so we can have a 2y as well then, right? Okay, so which one is easy? Equation number 3 is easy, right? So we are using that. So substitute into equation number 3. So equation number 3, copy. Yeah. So we have x equal to that, x equal to that. So when x equal to negative 1, y equal to negative 1 plus 3 over 2, -1. What do you get? Wait a minute. We have another negative sign in front, right? Can you see that? We have a negative there. So negative. All right. So can you calculate? So common denominator is 2. So 2 over 2. So it's a positive 1. 2 over 2 is a positive 5. Yeah. Okay. So when x equal to 3, we have y equal to negative 3 plus 3 over 2. So 2, 6. Negative 6. Negative 6 plus 3, negative 3, right? So negative 3 over 2. So critical points are negative 1 and 5 over 2 and 3 and negative 3 over 2. Oh, good job. Yeah. Okay, so we're not done yet. We're using second derivative test to find out local extrema, right? We have to have a discriminant formula. So let's find out discriminant formula. So let's use in this one. Okay. All right. So, oh, we have to have the partial derivative. Where is it? Everything. So we have to have this one. Copy. Okay. Is it G? Oh, yeah. G. Then we have to use G. So let's partial derivative with respect to x again. Second derivative. We get 2x then. How about partial derivative that partial derivative with respect to y, then y, 2. How about we need one more partial derivative respect x first, then y. Let me see, 2 again. We're using 2. Yeah, so 2. Okay, now discriminant. We have 2x, then y, so 2 minus 2 squared then, yeah? Okay. We have 4x minus 4. Okay, so we have x. So x not, y not is the critical point, right? So critical points. All right, so we have 2 critical points, but then we can use only x, right? Because there's no other variable beside x, right? So when x equal to -1 equal to 4, -1 minus 4 equal to um, -4, -4. It's 8, right? -8. Okay, then let's conclude. Oh, you cannot see. I'm very sorry. Let's conclude. So this is a discriminant, right? So we have one condition of discriminant, right? So let's find out. So we have one condition of discriminant is less than 0, then saddle point. Okay, so let's bring that. Okay, then we can say that the critical point is the saddle point, right? F has saddle point at the critical point -1 and what was it? -1 and 502, right? This one. Which is a critical point, right? Critical point. Okay, now when x equal to, so let's do one more time, this one. When x equal to 3, right? We have when x equal to 3, so 3, then we get +8. Okay, +8, then it's a positive, right? So d equal to, let me see. This is less than 0. This is greater than 0. If greater than 0, we have two conditions. So let's find out. Well, two conditions. We have local max, local minimum, right? It depends on the second derivative. So let's take a look. Greater than 0, two condition. Okay. If second derivative of partial derivative with respect to x is greater than 0, there's a local minimum. Less than 0, local maximum. Okay? So we need to find out. So let's copy. Okay. So partial derivative, we need only this. Oh, we have that too. Partial derivative, second derivative, this one, right? Copy that. Let me erase this one first. Okay. All right. So we want to know whether this one is greater than 0, less than 0, right? So we have to using x. So what kind of x we have to use? Same x, right? So we are using this x. So we have 2 times 3 equal to 6, which is greater than 0, then local minimum there, right? So if we have local minimum at the critical point, which is 3n, -3/2. Oh, you cannot see. All right. Okay, so basically, f has a settle point at -1 and 5/2, and local minimum at 3 and -3/2, right? So we have a nice picture. Okay, so this is the picture. Let's take a look. This is a settle point, -1 and 5/2, and then we can find the z. And this is a local minimum at 3 and -3/2. And if we plug it into the function, we can find the z coordinate, right? Okay. Let's do next one, absolute maximum, absolute minimum. Okay, so absolute maximum and absolute minimum, we talked earlier, right? So let's talk about the highest point for absolute maximum and lowest point absolute minimum, right? And also we say that this one in other textbook global maximum or global minimum, right? So we did that in calculus 1. Also in calculus 1 we had extreme value theorem. If the function is continuous over closed and bounded in AB, then f has absolute maximum and absolute minimum in the closed interval, right? So closed interval, we know that this is a closed, right, bracket. That means we include those points. And bounded means, for example, we have a sine x bounded by -1 and +1. In other words, we can say that -1 is bounded below and +1 bounded above, right? So bounded. So it's like that, right? Okay. Now, this is one example from calculus 1, how do you find absolute maximum and absolute minimum, right? So once again, the function is continuous. I'm trying to think. Continuous in the closed and bounded, right? Then there must exist absolute maximum and minimum at the same time, all right? Okay, so we have the polynomial, which is continuous, and then closed. Yeah, closed. So it should be, oh, parabola, open downwards. So like this, right? Yeah. Then just between 1 and 3, so include 1 and 3. How do you find the absolute maximum minimum? From calculus 1, we are looking for the critical point, one variable x. Then we do evaluate critical points and endpoint. Endpoint is 1 and 3 here, right? So we evaluate into the function critical point, what do you get? And endpoint, what do you get? Then we can determine which one is absolute maximum, which is highest point in the function value, right? And then we determine which one is lowest number in the function. That will be absolute minimum, right? Okay, now in calculus 3, we have theorem 4.18 extreme value theorem. The function is continuous. We have two variables, right? This is continuous. Sorry about that. So this is continuous. Continuous. And then I denoted CTS. on a closed and bounded set D. We have a set D, bounded set, all right? So D in the plane attains absolute maximum, minimum value at some point of D. D is bounded set. So closed and bounded set looks like this. This is closed. This is closed and bounded set. This is closed and bounded set. This is closed and bounded set. Okay? All right, now we have another theorem. They say that finding extreme value of function. So we can have the values at the critical points in the bounded set or boundary. Yeah, so boundary means this is a boundary. In the bounded set is inside. Yeah, is okay. So we can find extreme values means absolute maximum or absolute minimum, right? Okay, now we have example. This example crazy. Let's take a look. So we defined absolute extrema of the function on the domain D, closed and bounded set D. Okay? Defined by, it's given, this is given. So x is between 0 to 4 and y is between 0 to 2, which is closed and bounded, right? Those set. Okay, so 0 to 4, and we have equal sign. It's closed, right? And y is between 0 to 2, and also equal sign, so it's closed, right? So we draw the line is a bounded set. Make sense to you? Okay. Now, how do you find absolute extrema, right? So very similar with the calculus 1. But in that case, a little bit complicated, yeah? Because this is a bounded set. This is not just a function itself, yeah? Okay, let's do it. Yeah, little bit, lot of work, little bit, lot of work, lot of work. It's not like this, but we follow similar concept, okay? So, okay, let's do it. First of all, we need to find critical point. So critical point. Okay, so how do you find the critical point? Partial derivative with respect to x. So we get 2x minus 2y plus minus, so this is 0. Ooh, this is 0. And this is negative 4. And 0, 0, right? Okay, so 4. All right, so we cannot simply find the x values, right? So let's wait. So we want to partial derivative with respect to y. What do you get? So negative 2x, because x is constant. And second term, third term, so 8y plus 8y and 0 and negative 2. All right, so let's make a set equal to 0, right? Copy. Equal to 0, equal to 0. Okay, so we can see easily, we can get rid of x term, right? Just add them. So we get that. Then we get positive 6y and negative 6 equal to 0. Yeah. Okay, solve for y. So y equal to 1. Yeah. So let's talk about this is equation 1. This is equation 2. And this is equation 3. Then we can substitute any equation, right? Oh, equation. That's not the equation. So let's substitute substitute into equation number 1. We can do either one. All right, so we have that. Copy. Equation number 1. So substitute. All right, so we have a 2x minus 2y minus 4 equal to 0, right? Okay, 2x minus 6 equal to 0, x equal to 3, right? So we have critical points, x equal to 3 and y equal to 1. Yeah. Okay. Next, what we do. All right, so we have this closed and bounded set D, right? So we want to find the absolute extrema, right? Okay, so we just found the critical point. So we will evaluate the critical point later here. So we see how much we get, right? Okay, by extreme value theorem, right? So we want to know about the boundary too, right? So critical point and boundary, yeah? But in that case, it's not only boundary, we will do the vertex too. Vertices, all right? So this is a lot of work, so let's do it. So we denote, this is line 1, this is line 2, line 3, line 4. Okay, line 1, L1, it's a horizontal line, right? Okay, let me bring this picture. Copy. So we have this, right? Okay, for L1, so think the horizontal line. So if a horizontal line, how do we express the equation? Horizontal line. Y, right? Y equal to something. In that case, it's 0, right? So y equal to 0. Okay. Then we are using this technique here. So let x equal to t, y equal to 0. Okay. Then We have equation, original equation here. Copy that. Okay, then f, look, we said f of x equal to t, y equal to 0. Yeah, that means we substitute x is t, 0 is, 0 into the y, right? Make sense? Okay, then there will be t squared minus 0 plus 0 minus 4t minus 0 plus 24, right? So that is t squared minus 4t plus 24. Yeah. Okay. So let's say that this is g of t, or we can rewrite here g of t. Yeah. All right. Now, we want to find the derivative. Yeah, to find the critical point here. Make sense? All right. So g prime of t. So we don't have to do partial derivative because this is one variable, which is in terms of t, right? So what do you get? 2t minus 4. Okay, then we set equal to 0. Then what's the t? T equal to 2t equal to 4, t equal to 2. Yeah. So t equal to 2 means x equal to 2 because, oh, cannot see, huh? Because x equal to 2. Since x equal to 2. So this is the critical point. All right. So we will do line 2, line 3, line 4 with this processing, right? Okay. For line 2. So line 2, this is a line 2, then vertical line, right? Then vertical line, how do we express? It's the equation x equal to something, right? Okay, then we get x equal to 4. Then other variable, we can say that y equal to t, right? Yeah, this technique, we're using it, right? So x equal to 2, y equal to t. I'm sorry, 4. Okay, then we have f of xy equal to, let me just copy. Oh. Oh. Okay, let me just sorry about that. F of x, y equal to x squared. Oh. minus 2xy plus 4y squared minus 4x minus 2y plus 24. Okay. Then f of 4 and t. So substitute x into 4 and y, t into the y, right? So we have 4 squared minus, oh, it's not 0. So we have to do everything. Be patient. All right. So 2, 4, and y equal to t plus 4, t squared minus 4, 4, minus 2t plus 24. Okay. Whew. Uh, let's arrange that. So there will be 16 minus 8t plus 4t squared minus 16 minus 2t plus 24. Okay, combining like terms. So we have 4t squared by itself, negative 8t minus 2t. We have a negative 10t and plus 16 and negative 16, positive 24, positive 24, locally. Okay, now let's say that this is g of t, yeah? Then we want to find the critical point. So g prime of t, which is 8t minus 10, set equal to 0. And what's the t? T equal to 10 over 8, which is same as 5 over 4. Okay. So this is a critical point. Yeah. So basically, we have from the function, we find the critical point. We need to find all the critical point with from the lines, right? All right. So for L3, let's take a look. This is the one. Horizontal line, we have experience. This horizontal line, which is y equal to 2, right? Then other one is other variable, which is x equal to 2. I'm sorry, x equal to t. Sorry about that. Y equal to 2, x equal to think t. Think the horizontal line. Then say y equal to 2. So let x equal to t, y equal to 2. Okay. Let me try to copy the function. Copy. And f of x equal to t, y equal to 2. That means we substitute the t into the x, 2 into the y, right? So let's do it. T squared minus 2t x 2 plus 4 2 squared minus 4 times t minus 2 times 2 plus 24. Okay. Then that's t squared minus 4t plus 2 squared 4, 16 minus 4t minus 4 plus 24. Let's simplify. Combine like term t squared by itself. Negative 40, negative 40, that's it. Negative 80 And we have a positive 16 and positive 24, which is missing. Yeah, negative 4. So we get positive 36. Okay, let's say that this is g of t. Yeah, and then we want to find the critical point. That is g prime of t equal to 2t minus 8 set equal to 0. So critical point to t equal to what? T equal to 4. Okay, now almost done. 4L4, line 4. So let's take a look. Line 4 is a vertical line. So in that case, it's x equal to 0, right? So let's do the thing. The vertical line. Say x equal to 0. Then let x equal to 0. Other variable is the t. So y equal to t. All right. So f of copy. So f of 0t, which is 0 minus 0 4t squared minus 0 minus 2t plus 24, right? Okay, then we get 4t squared minus 2t plus 24. So we say that g over t, then critical point g prime over t, 8t minus 2. Then we set equal to 0. Then t equal to what? T equal to other side, so 2 over 8, which is 104, right? Okay, let's do it. We have a critical point, right? So that critical point we need to evaluate. And then also, I said it in the earlier, right? So we want to evaluate those points. Yeah. Okay. So basically, this will be like what is called? Those number will be just treat like a bracket, right? Closed, right? And then this one, we are using critical points, right? And also we have another critical point from the equation, right? So from the beginning, all right, your job is we need to evaluate all the critical points we had, and then all the vertices. Okay, all right, let's do it. So critical points, the first one is 3, 1. And from the line 1, we have 02. Okay, so 2, wait a minute. So if we have x equal to 2, that means y equal to 0, right? Okay, let's write down critical point. So here you go. Critical points 2 and 0. Critical points, let's see, 4 and t equal to 5 over 4. You guys okay? So x equal to 4, t equal to 5 over 4, which is y. And we have a line 3, t equal to 4. Which one has the t? X equal to t. So no, 4 and 2. Sorry about that. 4 and 2. Yeah. And then line 4 has, which one has t? Y equal to t. So 0, 1 over 4, right? 0, 1 over 4. Critical point. Okay, so let's evaluate all the critical points and vertices. All right. Note. Evaluate all the critical points and the vertices. Okay, critical points, let me write down. The first one, 31. Second one, from the line 1 to 0, line 2, 4, 504. 2, 0, 4, 504. And line 3, 4, 2, 0, 104, 4, 2, 0, 104. Let's just see that 4, 2 correct, right? 0, 104. 1, 2, 3, 4, 5. Yeah? Okay. That's the critical point. Vertices, we have 0, 0, 4, 0, 2, 0, 4, 2. Yeah? 0, 0, vertices, 0, 4, and 2, 0. Okay, hold on 1 second. I scroll down. Once again, bad memory. Okay, 4, 0. Yeah, 4, 0. 2, 0, 4, 2. Okay, 4, 0, 2, 4, 0, 4, 0, 0, 2. And the last one, 4, 2. Yeah. Okay, we can just using 4, 2 here, right? Oh, this is not the 0, 2. Okay, so let's do it. We have the function, the original function. We need that. Just we need to evaluate. And then we want to know which one is the highest one, which one is lowest one. Okay, your turn. Please do it. 31. 3 squared minus 2, 3. 1 plus 4, 1 squared minus 4, 3. Oh, 4, 3. Minus 2, 1 plus 24. Ooh, I need a space. Almost done. In there. Okay. This 17. Please check it out. Yeah, 17. Is it correct? All right. Now, f of 2, 0. So 2 squared minus 0, 0. Good. 4 times 2 minus 2 times 0 and plus 24. 2, 0. It's 20? Okay, now we have a 4 and 5 over 4. 4 squared minus 2, 4 times 5 over 4 plus 4, 5 over 4 squared minus 4 times 4 minus 2, 5 over 4. I need a space. There you go. And plus 24. What did you get? 4 and 5 over 4. This is 17.75. Did you get that? Okay, so we have f of 4, 2. So 4 squared minus 2 times 4 times 2 plus 4 times 2 squared minus 4 times 4 minus 2 times 2 plus 24. 4 and 2. Oh, it's 20. Yeah. There is a shortcut. And we did already. After this, I can show you shortcut. So for 2, 0 and 4, 104. So this one has 0, so it's not too much. Okay, so 0, 0, 4 times 104 squared minus 0, 2 times 104 plus 24 equal to 95 over 4. Yeah. So this is approximately 23.75. Okay, so I said a shortcut. So what is this shortcut? So shortcut. So from line, let me see. This is from the line 3. Line 3, we have the t function, right? So g of t equal to t squared minus 8t plus 36. Yeah. So we have this one come from 4, 2. So 4, 2. So we have a 4, 2. 4, 2. So this is we have to take a look. Sorry about that. Make you a little bit confused. So this is a line 3. We have a 4, 2, right? So x equal to 4 then, because x equal to t, right? So we have to take a look which one is t. So 4, 2. So we substitute when t equal to that, right? Because we don't have a y, right? Then we get the same answer. So let's do it. So this is t. X equal to t. So we are giving to the t. So g over 4. 4 squared minus 8 times 4 plus 36. Can you check that we get the 20? Yes? Yeah, this is a shortcut. Yeah. So we did not have to everything for the line, only the line, because we have a t function. Yeah. So we can just using what's the t value, just a substitute. Make sense? Yeah. Okay. Now, vertices, right? So I think we finish all the critical points. Now, vertices. All right. So 0, 0. So plug in 0, 0, 0, 0, then we get 24, right? How about 4 and 0? So plug in 4 squared, 0, 0, minus 4 times 4, and 0 plus 24. 24? Okay, now 0, 2. Oh, you guys cannot see. 0, 2. Okay, on the top, we barely can see the function 0, 2. So negative 2, 0. Second term also 0. Third term, 4 times 2 squared, 0, minus 2 times 2 plus 24, 0, 2. 36. Okay, the last number 4, 2, 4, 2. Oh, now I cannot, 4, 2, we have that one, right? 4, 2, luckily, this 4, 2, same as a 4, 2, right? Okay, so we have 20. Also, shortcut, I showed you 20, right? All right, so we're looking at all the values, function values. Yeah? What do you get? Which one is the highest one, the lowest one? Okay, let's talk about the highest one first. Which one is the highest one from here? 17, 20, 17.75, 20, 23.75, 24, 24, 36, 20. Okay, so 36, yeah? So this is absolute maximum, yeah? Highlight. Oh. Mhm. Sorry. Okay, how about absolute minimum? The lowest one? 17 or 17.75? Which one is that? Yeah, 17. So 17 is absolute minimum. So I have to make that like this. I have to make this. Yeah. Let me bring the picture here. We did a lot of work. Okay, so here is the picture. So we had the book indicate the global minimum. So we had absolute minimum, right? When x equal to 3, y equal to 1, then z equal to 17, right? So here 3, 1, 17. This is the global minimum, right? We had the absolute maximum when 0 to, when x equal to 0, y equal to 2, z equal to 36, 0 to 36 is the absolute maximum, which is global maximum if they want to denote, right? So global, not the local. So global, absolute, yeah. So like absolute minimum, maximum, okay? All right. Any question? Thank you for watching. I will see you in next section. Bye.